All right, everybody. Hi, I'm Kevin Czajkowski from the University of Toledo, and welcome to our Globe Mission Earth webinar for tonight. It's going to be on urban heat-island effect and surface temperature and the Globe Surface Temperature Field Campaign. And I think we have a pretty good lineup for tonight. Remember to mute your line if you can, or your screen. Now, Janet can mute you as well, but it's sometimes hard to find everybody, I think. So everybody mute your line, please. All right, we're getting close, I guess, everybody. Let's see. I'll start like I start all the webinars. Yeah, we have some pretty good feedback, Janet. Let's try and mute everybody. All right, so here we are. So just a little bit, I don't know if everybody has heard me say this before, but Mission Earth is a project with NASA, the University of Toledo, West Ed, Boston University, UC Berkeley, and Tennessee State. So if everybody could mute their line, that'd be great. And then here's our speakers for tonight. We have Jim from Lake High School. I got the side view of you, Jim. Actually, Sarah's not talking. She said Jeff Luvall from NASA and Matt Silberglitt from West Ed. All right, so this is going to be our lineup. We'll have Jim do the teacher feature and then a research section by Matt, our NASA Nugget by Jeff. So just going back to why do we do all this? Because it's the reason we want students to do research projects and then present those projects at meetings. And there's opportunities to present. So we have a deadline now for the virtual science fair. It's April 3rd, so students need to get their projects in by April 3rd for those to the Globe website. We have the regional science fairs coming up as well. I think they're called Symposium now. So Globe Regional Symposium. And the one in the Midwest is going to be the second week of May at Purdue University. We also now know the annual meeting will be in New Haven, Connecticut. And these are examples of students presenting, and it's between July 29th and August 5th. So it's a great time to have your students make their way to Connecticut, present. There's a student research project usually along with that. So tonight we're going to talk about urban heat-island effect and surface temperature. So our surface temperature field campaign is coming up in December, although you could start earlier if you wanted. And I know a number of schools are starting to take observations already, especially after Thanksgiving. You could start, the end of November there. And a couple of things we want you to do: have the kids develop research questions if you can. Why are they taking these observations? It's important for them to think about that, and may come up with a question for their own schoolyard. We would like you to have your students take at least 2 different cover types, the temperature of 2 different cover types. Grass in a parking lot are pretty typical things that students will take the temperature of it. And then they have different temperatures because of the, their cover type. And then lastly, if you could do 10 days in December, 10 different days of observations, that would be good to get enough data. All right, so I'll stop sharing. And Jim is the next presenter. So Jim Less from Lake High School. And he's going to show, I think there's a video first.
Yeah. I will be talking during the video. I have to make it full screen. I'm sorry.
Okay. Well, thanks, Janet.
Well, actually, I want to thank Sarah and Janet and Travis. They came out to Lake a couple of times and helped me and the students with the testing, and took a lot of pictures and videos. So we really appreciate your help, and looking forward to showing the video. This is here it starts. So I'll let it kind of go through, and I can say a few words afterwards. And we're in Millbury, Ohio, which is east of Toledo a little bit.
Program with students all over the world, and we're going to collect data here at Glick High School, put it on the internet, and other students can view it and use it, and even more important, other scientists and researchers can use it. And here at University of Toledo, we are going to participate in surface temperature campaign. The actual campaign starts in December. We're going to start learning how to use infrared thermometer early in case you want to use it for a science project. And there'll be other applications for it also. This is number one. It has to be, I guess, protected from what's called thermal shock. And that's not anything that's going to shock you. But the instrument, for it to read accurately, can't go from a very cold place to a very warm place, or from a very warm place to a very cold place. So you usually want to move it outside or into the area where you're going to be measuring, like half hour to an hour beforehand. For that reason, I'm keeping our IRTs outside, so I'll test them outside once we get outside, so that it's used to the temperature we'll be using it. The other thing is we measure, whenever we take temperature measurements in science class, we're going to use the Celsius scale. So you'll notice there's a little switch that flips between Celsius and Fahrenheit. Make sure your measurements are in Celsius. The other thing, since we're measuring surface temperature, or the surface of the ground, we need to have this aim straight at the ground. Okay, so the best way to do that is to keep it at your shoulder length, with your arm extended, and pointing straight down. And you just press the trigger, hear it click, and you take the reading. It's that easy. So
There was 3 places where we tested, so Sarah outlined them on the map.
okay, so hold it straight out, face up. Okay, there you go. Make sure, one more thing, make sure there's no shadow for your measuring. Okay? No shadow. And you're reading it in Celsius. Okay, so Bronson, you tell Tommy what the reading is. Tommy, you record it. Okay, do that for the 9 reading. And Dave, you're going to do some based off of this area. Okay, we're going to find the area. Walk around, find a different place, okay? Okay, you don't stay at the same place. Find other readings. Let's find the area. Okay? Yeah, just do the full grass here. You can, and then the rest of it, you just walk all over the grass and take your 9 measurements.
And we also practice pacing our study areas and did testing on concrete as well. And practiced recording it using some of the data sheets. Okay, so that's the video. I'll just say a few things. It looked like quite a few people doing a couple things, but it was about 15 students in the class, and I had them divided into groups of 3, and then we picked 3 different study areas. That way, I was hoping each person would get a chance to use the IRT, and another person on the team would pace out the study area, and the third person would do the data recording, so record it on the data log. And then they would rotate as they moved to a different study area. That seemed to work pretty good. I'm sorry, was there a question? Okay, and then, so I did this with freshmen, and it was at the beginning of the school year. So back early in September when we started doing this. And actually now some of my students are doing their own collecting their own data for their own science projects. And I've been relying on University of Toledo's help throughout the entire school year so far, because they do provide us with equipment on loan. It's almost on a weekly basis. I was stopping by and visiting Janet to pick up some new equipment and dropping off the old equipment. That was really nice. And we are still borrowing some for the science projects. So I want to thank you for that. And I know the students love going outside and doing the work. It was kind of like our Friday field day is kind of how we set it up. So during this week, we'd do regular classwork, and Fridays would be our field day. And just one other thing I'll mention is, this is just kind of a comment from one of the students, and it wasn't even prompted or anything, but just walking back from the ditch one day where we were doing some hydrology testing, so unrelated to the surface temperature measurements, but he made a comment like, this is the first time that he's ever done real science, and he was just so excited. So that was good to hear. This was a good student that said that. So I think it's been successful. Again, this is my first year doing it with my students, so it's a learning experience for me too, but it's been very positive. So I guess I appreciate you featuring us on the webinar tonight too. So, thank you. That's about all I have to say, unless there's any questions.
Yeah, does anybody have a question for Jim about how he's implementing surface temperature observations in his classroom? That's a dramatic pause.
Okay, I guess.
Laura has a question.
Yeah, okay. I just figured out how to unmute my mic. Hi, Jim. I have a question. So you said that your students are doing some science projects with surface temperature. Can you give an example of maybe the questions that they're investigating and what their experiments are?
One of them, they are actually trying to see if there's a connection between relative humidity and surface temperature. So so I'm borrowing a sling psychometer from Janet, and they're having fun using that. They're taking relative humidity and temperature readings, and then also surface temperatures. So a lot of the students are just trying to compare, see how different factors in the environment affect each other. So that's kind of what they're investigating. That's one group. As far as I recall, I think that's the only group that's doing it. A lot of the groups are doing water testing or soil temperature, soil moisture testing also.
Very cool. And did you come up with those questions for them, or did they?
No.
How did you set that up?
They came up with their own questions. I just had them share them with me and would talk them through what their ideas were.
Do you have any tips on how to guide them to come up with those questions?
The Globe website, and under the tab for student, the student section has a student research section, and there they do go through the research process on a student level, and they do have a section or a menu item that talks about how to make a good question, and there's actually a checklist that that I printed out for them that they could use to see, if their question is meaningful and if it's more than just a yes/no question, and if they can learn something from it. So I kind of walked them through that, and I showed them some of the protocols on the Globe site, and and actually throughout the beginning of the year. So this is our Friday field day. We spent probably a month just going over the different types of field equipment, so they got used to using it, so that they had some experience already with the equipment, and then they could kind of decide what they like using and formulate questions based on their experience, I guess.
Great job. Thank you.
Oh, you're welcome. Thank you.
So Lynn posted a question in the chat box, and she asked, is this just one period or several periods?
No, this is all of my students. I have, it's all pretty much freshmen. I have six classes of freshmen, and their ability levels range from honor students, which are very high achieving students, to very low students who are every single one of them's on an IEP and functioning way below grade level. But they all can do this type of work, you know. And class sizes range from, my smallest class, which I'm very fortunate, is 9, but my largest is 27. So on average, they're like 16 to 20 class size. And you know, Janet and Sarah saw them, especially towards the end of the day. They get kind of on their own, I guess. They just they get kind of they just really like being outside, so they get kind of ready for something outside the classroom. So yeah, it is good.
We all like to be outside, don't we?
Yeah, for sure. I take any time I can go outside, I'll take it.
Yeah, David asked if you had them enter the data or do any of the visualization.
They are, we're getting into that. So when we were learning how to use the equipment, I didn't feel like I felt it was too much of a learning experience. So I didn't know if the data would be valid to enter. But we're going to be entering their data now. So we're getting into using the Globe site. So I haven't entered it yet, but as they collect data for their science projects and for the campaign, we will be entering data. But we have looked at the websites though.
Mm-hmm. Okay.
Yeah, were you gonna? I'm sorry.
Go,
yeah,
David.
Were you going to do the data entry in class or have them do it on their own?
No, we'll do it in class. I'm allowing time in class to work on it.
Good.
One of the things that we're kind of lucky at Lake is every day we have, it's like a 20-minute period. It's called ICE, but it's kind of just like a free period where students can get either, if they need help with the teacher, they can use that time. They can use it as a study hall. But I'm having kids come into my class that are working on science projects to work on it during that time. So we do have some free time throughout the day where we can, it's not structured, that we can utilize.
Just having a discussion on the chat about snow and kids going outside when it's cold. All right, well, thanks, Jim, for your insights and demonstrating with your kids how to do it. Now we're going to transition to Matt Silberglitt from WestEd, and Matt might help if you introduce yourself, tell everybody what you do, because I'm sure not many people know what WestEd is.
Yeah, thanks, Kevin. So WestEd is one of the partners on the grant, and WestEd has been working on the GLOBE program for a while, mostly with a program called the California Career Academy Program, where high school academies engage in GLOBE over several grades, and students develop an understanding not just of how to collect GLOBE data, but how to make sense of it, and they develop projects over those 3 years. So there's some nice continuity there. There's a nice framework that we have. And under the current program, we are continuing to work with high schools in the California Bay Area and Sacramento. I personally have a background in assessment at all levels, including the rubrics that you may have seen. I worked with Julie Malmberg at UCAR on the rubrics that were used last year for the International Virtual Science Fair, and we've updated those, and those are posted. I also worked with judges at JPL for our Pacific Regional Fair. And one of the things that we noticed in looking at many projects, both from international and from the regional fair, are some issues with research questions and what students think the purpose of research questions are and how well they're able to connect the research questions to the research itself. So a lot of variation there. Obviously some fantastic projects out there, but just noticing some issues for some students. I'm going to share a training piece that we used in our recent training for our Bay Area and Sacramento area high schools. We had Janet Struble was able to come out and observe that training, and we had several trainers, including myself, who had pieces of the training for our teachers. So I'm just going to share that piece with you all. I would like it to be interactive, although I realize we're bound by time and there's lots of people on the call and it might be hard to all talk. So what I've prepared to share with you is some of the things that we asked the teachers during the training. And then I'm going to also read off some of the kinds of things that we got as answers from our teachers in our training. But at the same time, I'm going to take a look at the chat. So if folks want to answer while I'm listing off some of the examples that I have already prepared for today, please do chime in through the chat, and I'll try to make sure to pay attention to that. And Kevin, I see you're being very helpful in letting us know when there's things popping up in chat. So if for some reason I missed something.
Right, I'll read it.
Yep. Okay, thanks. So let me switch over to sharing my screen. And go into presentation mode. So hopefully y'all can see that. Okay.
Yes, we can see it.
Okay, thank you. So the focus on today's session is not about how to write research questions so much, but how as teachers we can provide guidance to our students. And I really appreciate Laura's question. It's a great segue into some of the things that we're going to talk about. And Jim, your answer about the Globe page, great resource. We're not going to go into that right now, but just to give you some examples of strategies that we developed and shared with our teachers and feedback that we got from our teachers about how to frame research projects for students so that they're not just doing anything, because we don't want them just coming up with anything under the sun. It has to be feasible, it has to be on topic. But we also want students to feel like they have some agency, they have some buy-in into this process. And we know that when students come up with their own research topics and they're collecting their own data, that is far more meaningful to them. And we just saw that example of the student who said, you know, we were doing real science today because it belongs to them. They have some ownership over it. So we start by asking the teachers, well, what are some research topics that fit into your curriculum? Because we're trying to help them integrate Globe into the curriculum and not have it be an add-on. And because we're in an academy setting, we have teachers of various topics from environmental science, where we'd expect to see it, including biology, chemistry, physics, other topics, other subjects perhaps, where we really are trying to fit things in. And we have some different models because we're working with schools that are doing project-based learning. We've had a couple of MET schools that have the big picture approach. So we've got some different contexts out there, and we want to make sure that we're not trying to just drop Globe in, but rather have it be integrated in a way that's meaningful. So I'll mention some examples of research topics. The first one that came up, of course, was El Nino. And I think we're looking forward to a La Nina. So if you look at the Globe campaign for this, it's referred to as ENSO, the El Nino Southern Oscillation. Others were air quality and water quality. Those are big issues in our area. Extreme weather, global climate change, and of course, drought. If you're in California, you know, you're really paying attention to drought, although less so right now because we've had some rain, but it's just a drop in the bucket. So let's see, how do I?
Are you trying to unshare?
No, I'm trying to peek at the chat. I'm used to a different.
Oh, there's so far there's nothing. I'll tell you if there's something on the chat.
Okay.
Don't worry about that.
Okay. Let me go back now because I clicked on it. And then following up from.
I'm posting something on the chat about El Nino. So maybe I'll just say it. I've started with my pre-service education majors today, having the students look at Globe for data that corresponds to El Nino, and then seeing, well, does it impact those regions like it was supposed to, using the you know, the kind of impacts that you see online, you know, California, Peru, Australia, that type of thing. So that's what they're going to work for about 2 weeks on this project.
Yeah, it really is a great opportunity for students to do research, and we did have some projects in the regional that looked at El Nino's effect on local weather, and it really was an unusual year for it being an El Nino year. A lot of the rain last year missed us. It went north and hit the state of Washington. Of course, that was up in the news, and it was too big. El Nino was too big, and so it pushed that rain further north. So it was an interesting phenomenon for that El Nino event. So then the next, well, let's talk some of the other topics, and I already listed those, sorry. What are some learning goals that we can address? And we'll get into that in just a second. Does the research topic provide opportunities for students to develop their own ideas? That's a way of evaluating that topic. And does the research topic provide limits to students to ensure that their ideas are relevant to GLOBE? So these three questions are really designed to help teachers think about the research topic as a way for setting the stage for their students to succeed in writing good research questions, but it's just the start. So hopefully the answer to the the third and fourth question are yes. So the one that we focused on, the topic that we focused on was air quality. And we asked the teachers to think of the kinds of things that students might come up with, and then asked them to think about, well, what knowledge do students really need to answer that question? And in particular, what are the science practices that students need to use and master? And I realize we're talking to a wide group here, and while NGSS is pretty prevalent, it's not formally adopted in every state. Practices is a word that's been made popular by NGSS, and it's what we used to call inquiry. But it's a broader set of things than just than what we might have seen in the previous set of standards. So some examples, and I've reframed these to be more general. Many of these were very localized for the area where the school is. For air quality, how does traffic affect the air quality by our school?
Now that's a good one probably for aerosols, if someone has an aerosol instrument, to possibly do closer or farther away from the school.
Yeah, and I'm remembering that did come up in the training, the aerosols protocol. So what learning goals could be addressed with research on air quality? Well, first, all of the practices can be addressed, and I'll talk about that in just a moment. But when we're talking about air quality, some of the things that might come up for different teachers, and it really depends on the subject that you're teaching, but the composition of the air and how it changes, looking at sources that could be affecting air quality, and the consequences of pollution and who is affected. So looking at those human impacts, for example, or environmental impacts. So these are the practices from the framework, which precedes the NGSS and is really the document that teachers need to know more so than the NGSS per se. And as you think about when students are doing research, they really are going through all of these different practices. They're asking, obviously, research questions, so that's number one. Hopefully they're planning their investigations, collecting data, analyzing and interpreting it, doing some visualizations, and then at the end, explaining their findings and possibly supporting some claims that they may have with evidence from that investigation. So one of the nice things about GLOBE projects and these research projects is you can really cover all the practices if you're concerned about taking time to do GLOBE during the regular school year and making sure that GLOBE integrates well. This is a great rationale for bringing in GLOBE projects, that you can do all of these things that you need to cover over the course of the year. So let's get to the feedback. And these are some examples that we shared with the teacher group to give a sense of how to guide students without just coming out and saying, well, that's not going to work, or telling them that their question isn't good. That's obviously not what we do as teachers. Usually when students ask us a question, we respond with another question, like, well, how are you going to do that? So how will El Nino affect global warming? What will the weather be like near our school this year? And how do large rain events in our area affect the water quality in a local creek? And in this case, that last one was actually a specific creek that's in Oakland. And these are somewhat modified for simplicity, but these are things that we saw in student research, either in the classroom or in the regional or international fair, things like this. So again, if you have any thoughts, feedback that you would give to students on these, please post them in the chat.
Well, Matt, one of the things I think how will El Nino affect global warming? That's a tough question, although there's certainly, you can see correlation on El Nino years and the global temperature. So it's tough, but I think it's actually doable from a big picture. Now, I'm not sure how that would involve globe. What do you think about involving globe in that question?
Yeah, and that's exactly the kind of question that we talked about with the teachers in our training. When we're faced with something like this and our students are in front of us and we have to respond in a way that's positive and encouraging, it's difficult. But I think the solution is really to push the students to think ahead, think strategically about the research. And this is where I certainly saw in some of the projects a disconnect between the research question and the research, because students pretty quickly realize once they start doing the research that they can't directly investigate this question. And especially if you're looking at the campaign that we're looking at now and we're saying, let's take measurements for 10 days. It's not going to happen. So one way to get students to think ahead is to give them examples of data they might collect, or if they're already familiar with GLOBE, to have them consider, well, what data would you collect to answer this question? But I think the important thing is for the students, after they think ahead about the data that they're going to collect, that they don't just go out and collect it, but that they revise that research question. And that's, I think, the difference between a project that really holds together well when you're looking at it as a judge in the symposia or in the fairs. One of the things that's really clear is the students who really have a clear sense of the logic of scientific research, and students who have lots of good ideas, but they're very disconnected. And so they might start with a great question that's a really broad question that we'd all love to know the answer to, and then they take 10 days of data collection and they give you their findings and they do nice data displays, and then they write some nice conclusions based on the data, but the conclusions and the data don't address the question. And so I think if we can give students a chance to think ahead, if they know what options there are for them to collect data, and they know that it's going to be a certain time frame, or that they plan that time frame, if they have more flexibility and they have choices around how many days they're going to collect data or how many months they're going to collect data, having them think ahead and then consider how the data that they really can collect in the scope of a project that happens within a school year or shorter can really address a good research question and give them the opportunity to narrow that down. Make it more specific. The nice thing about that last one, when you see it in its actual context, it was specific to a creek here in Oakland. A connection to a specific location or a subject of data collection really makes the question doable. It also builds some investment from the student in the question. If this is their local community and they're finding out something about a place that they care about, that promotes a lot of buy-in. So give them that opportunity, because they might not do it on their own. They may give you what they think you want to hear, which are these grand questions that we all love to have the answers to. But that's, of course, not realistic for these students. Other feedback that our teachers suggested for our students, make sure that there's some tangible impact. Something like the last question really gives students a sense that they can make a difference, because they can communicate this to the community, for example, or to if there's a local township or whatever, the commission on water quality, or people that make decisions, that they can have an impact by sharing findings.
Well, Carol posted on the chat that in North Carolina they had 2 large next to each other, and then several weeks of no rain after that.
Kevin, you dropped out, at least for me, so I only heard the first and last sentence or segment of that.
Yeah, sorry. Yeah, I noticed my internet like cut out, I think. Well, anyway, there's a Carol made a posting in the chat room, so maybe go look at that.
Okay. Yeah, I wish I knew how to peek at the chat. Oh, there it is. Let's see, I like the idea of large rain events. Here in North Carolina, we had 2 major storms back to back, followed by no precipitation for weeks on end. The kids have really noticed this, and they're starting to connect the dots. That's fantastic. Lynn Powers, building a matrix of questions, types of observations need to answer, the questions, protocols, and equipment needed. I like this. Yeah, it's a great way to get students to share. One of the things we did with the teachers, we had a gallery walk around the research topics and research questions, but it was what we might call an enhanced gallery walk for those of you who have done this. And we gave everybody stickies, and we had them go around to each of the topics and add ideas for research questions that they thought their students might come up with. And then they went around and looked at data sources, both GLOBE data sources and NASA data sources that might be part of that research. And then the teachers could take that piece of chart paper that was part of the gallery walk, fold it up, and take it away from the training. And they really had a tangible benefit from the training that they walked away with, that theoretically they could start using the next day in their classes.
All right, Matt, we should probably wrap up this section and then move on to Jeff's.
Thanks, Kevin.
All right, so Jeff, Dr. Cool.
Okay.
That was on your name. Well, I'll let you introduce yourself, since I know you work with Dale Quattrocchi on urban heat island effect, and you're at NASA Marshall, I believe.
Right. Yeah, I did. Just a little background. I was actually one of the first, started on GLOBE, one of the first scientists that did some of the protocols and stuff. Our chief scientist at Marshall was the chief scientist of the program at the time. So started as GLOBE way back in the beginning. So it's interesting to see how it's progressed over all these years. The Dr. Cool came from one of our projects out in Salt Lake City, where I was having kids take air temperature measurements when I was flying over with aircraft to measure the surface temperature. And I had about 300 school kids out taking temperatures and stuff. And then they developed curriculum and this sort of stuff. And so they call themselves Dr. Cool. And it was a lot of fun. That was way back in the late 90s. So anyway, today I'd like to just talk about some of the urban heat island work I've done over the years and the instruments I use to take the measurements, and just to give you an idea of what the large scale looks like when you're using from one of those handheld IR guns to an actually instrument that actually can measure that temperature from aircraft and space. So I'll go ahead and get this share screen and get this presentation up. Okay, one of the major things that we do to our environment is process of urbanization. And when we urbanize an area, it obviously really impacts not only the immediate area, but the surrounding countryside. So one of the oldest phenomena that was observed back in 1820 in London, actually did measurements of urban heat island in the heating of the city of London. So it's a phenomenon that's been known for a long time. And you can even see this phenomenon in small areas where the energy that's been absorbed during the day from the urban surfaces is released at night and warming the air. And of course, the magnitude of that temperature difference depends a lot on the local meteorological conditions and the size of the urban area and the seasonality and that sort of stuff. So one of the things that we've been interested in and been doing over the years is trying to understand what the urban fabric is that produces this urban heat island. So obviously, if you're looking at an urban area, it's very large, and there's not really a good way of measuring temperature, either air temperature or surface radiant temperature from the ground. So this is where the technology that NASA's developed over the years to observe the planets and even do some geological research is applicable to looking at our cities. So I like to go through some of the things I've done over the years to do that. This image is of the eastern end of Puerto Rico. And on the eastern side is the El Luque rainforest. It's a national forest. And as you can see, you can easily see the boundaries of the national forest, and you see where urbanization is encroaching right up to the boundary, and red's hot and yellow's less hot, and then how cool the forest is. Well, I think most people don't realize the impact that urban areas have on health. Heat-related deaths are very high. Most people don't realize that. And heat waves, when they occur, thousands of people can die from the increased temperatures within these urban areas. And this is worldwide. In 2003, Europe, 35,000. Russia, in New York. So, it's not limited to the warm climate, so to speak. In fact, areas that are more temperate and have more strong seasonality may actually have more deaths related to heat stress because they're just not prepared for extreme temperatures. I think a good example is Chicago. That was really an awakening when that many people died. Well, on the other hand, people like to take and blow this out of proportion, claiming that with the climate variability that this problem with urban heat island effect and heat-related deaths is just going to increase, and this is really nonsense. They have no basis for making these statements, but it makes good press, and I like to see, this is what Atlanta's going to be like in 50 years. So But anyway, NASA has a wide variety of both satellite systems and aircraft sensors that can be used to study the urban heat island effect. And this is just a whole suite of satellites, not specifically for making measurements of the urban climate, but just of all kinds of measurements of the Earth ecosystem, environment, atmosphere that are being made with NASA instruments. Okay, so the real question is with the urban areas is what happens to the sun's energy, particularly in urban areas. So it can be quite complicated, and there are a lot of equations and math and everything, but it really boils down to very simple. The urban surfaces are usually either darker than the surrounding country. They're made of materials like asphalt that are dark and absorb heat. And depending on the urban areas, there are not a lot of green areas. Sometimes there are, just depends on the city. But what happens is those surfaces are very efficient in absorbing the sun's energy, and they store it, and then at night they release it. And so that air temperature is coupled tightly with that surface radiant temperature and the water status of that surface, i.e. soil moisture, because if you have a green surface, a lot of that energy is used to evaporate water and it doesn't heat the air. So it becomes a very complex relationship in which urban areas do alter the climate, and we can make choices on how we design our urban landscape to minimize that impact. So this is a classical sketch that we did when we were working on an EPA project of what the urban heat island is. And, you know, depending on where you are, it can be 10 degrees Fahrenheit difference in the city and outside the city. And this also has a big impact on air quality. When you increase temperatures, you increase the amount of precursors, the biocomponent, the trees, all the stuff the trees release that make up the soup, along with nitrous oxides, combustion products, and the sunlight to produce ozone and other air pollutants. So cooling the city may have an impact on reducing some of the problems with particularly ozone. We put together this little video when we were working in Atlanta to kind of look at the impact that the urban area has regionally. So if we look at the central business district of Atlanta and overlay what the temperatures would be, and then kind of pull back and see the extent of urbanization, particularly we've looked at the growth over 30 years, how that gets very warm, and then you look at night and you can see that urban core and how warm it is. And as you can see, the growth from 73, you can see the massive amounts of alteration in the land surface and the corresponding heating of the area. Well, this has some other major effects. This is an actual GOES image. We took a series of images, and what it demonstrates is that Atlanta creates its own weather. These precipitation, or these thunderstorms, were generated because of the impact that city had on the boundary layer. It caused instability and resulted in convective thunderstorms being produced. And what happens in these urban areas, they not only can increase the precipitation, it changes the timing of the precipitation and the location. So a lot of this precipitation occurs downwind of the city. So there are a lot of impacts urbanization has on the environment. So if we're at ground level and look, we're using an IR camera, this happens to be a parking lot, well, Walmart in Athens, Georgia. look at the temperatures. Of course, you point your IR gun to the sky, it's essentially absolute zero. But if you look at the asphalt, it's over 40 degrees Celsius, and you see the tree and the shade that tree produces, and you see that's a considerable impact on the temperature of that asphalt parking lot. So we all know if on a hot summer day, if we have a choice in the parking lot, we'll park our car under a tree. And so this is one way through planning that you can reduce the impact of heating of these surfaces by simply shading with trees. I want to show you one of the areas we flew. Tropical areas also have problems with urban heat islands. This happened to be Puerto Rico, and you saw the one image on the first slide. And Puerto Rico it's a very dense urban area. There is some green areas and trees and stuff, but it's kind of unique in that most of the urban area, even though it's very dense, it's only 1 or 2 story houses. So, each city is very characteristic in the urban fabric, how it's designed, the materials, population densities, roads, etc. And so, you really can't generalize. You really have to measure each city. So typically what we've done in the past, this is a NASA Learjet, we would take and fly over these cities using an instrument called an atlas, which is essentially like Landsat, has basically the same wavelengths as Landsat, except that we've got more thermal channels. And if you look, the TM bands and the MSS bands, it's pretty close. But the unique part of this instrument, it has 5 thermal channels, which allows us to do very accurate surface temperature measurements. And so we just lay out a grid and fly over the city. And I was talking earlier about the mitigation strategies. One of the projects I had many years ago with EPA was, okay, how can we mitigate this urban heat island? And first you got to be able to measure the urban fabric, which we did with the aircraft, but things like albedo modification, light color roofs, so it's lighter color and those surfaces won't absorb the sun's energy and it stays cooler. Plant trees and increase green space, shade buildings and this sort of thing, rooftop gardens, a lot of things we can do. And in fact, one of the ideas with our EPA project was that the states would get SIP implementation credits when they exceeded ozone levels, and if they would use some of these modification strategies. And so we worked very closely with EPA, and they actually came out with a recommendation that they'd give them credits for this. And this really has a huge economic impact on these areas, because if they don't meet air quality standards, they get highway funding yanked, and Atlanta lost $58 million in highway funds. So there's a real economic impact on this. So if we look at some actual images taken from the aircraft sensor, this is a visible composite like you look out an aircraft window, 5-meter resolution over one of the parts of San Juan in Puerto Rico. See the rooftops and this sort of thing. But, the real story is if you look during the day what the surface temperature is, and you can obviously see usually your roofs are the hottest. Depending on the road surfaces, they're not particularly hot, but they are hotter. But you can easily see the cooler vegetated areas throughout the area and a few scattered clouds. And the real dark areas are metal roofs, and their emissivity gives you the impression that they're cool, but they're not, because they're not emitting that energy. And then if we look at that corresponding area at night, you can see what really retains that energy, the roads. And you see some of the clouds, and the green spaces are cool. But, roofs may get the hottest during the daytime, but they don't have a lot of thermal masses. The asphalt surfaces are the main surfaces that really hold that energy. So things that in the future that can make these measurements, we've got an instrument going up on space station. It's supposed to have been next year, but the Falcon SpaceX blew up once and pushed us back a year, and then it blew up again, and I'm not sure if we're pushed back how much longer. We're tentatively launching in May of 2018. This provides surface thermal information from the space station, which is going to be very useful. The other interesting thing about space station is that the way it orbit is, it gives us different times of overpass. So this helps us look at how the surface temperature changes over time. And we also get a day-night pair. The other instrument that hopefully will get built is called the Millbury, and it's a thermal and a hyperspectral instrument, 60-meter resolution thermal, 30-meter resolution hyperspectral, 5-day repeat in the thermal, 16-day repeat in the hyperspectral global mapping mission. And this will give us the ability to go globally and make these kind of observations from all urban areas across the globe. We're not sure when this is launched. I've been working on this since 2007. It made the second tier of the Decadal Survey missions, which meant that if there were funding available, we'd fly. There wasn't. The second Decadal Survey is underway. We're hoping that we'll still be on, we'll be called for to do the mission. We don't know. That'll be determined next year. But this is really critical for continually these observations. Just some background reading. Dale and I put together a book several years ago on just how thermal data is used in land surface processing, all kinds of information. We just signed a contract to do a second edition, and we've updated it with a lot of stuff. So this is just really a quick, broad brush overview of some of the work I've been doing in the last 25 years or so with Dale. I think, the type of measurements you're making is really critical and help communities understand the impact of urbanization and help the kids understand that too. So anyway, I think we got time for a few questions.
Thanks, Jeff. Mark posted in the chat, he said that Southern Georgia had experienced a drought a few years ago. Did the weather change from Atlanta intensify the drought?
Probably not. That's probably a little too far away. Typically, what an urban area does is it increases the instability of the boundary layer. So you get more turbulence and more chances for convective thunderstorms to occur. But that's not, reaching clear down, 200 miles away in the Georgia. But that's not saying as these mega cities develop in the future that they're not going to impact larger areas.
All right, so what questions does everybody have for Jeff? And Jeff, if you want, you could stop sharing your screen.
Okay.
All right. So questions for Dr. Kool. Oh, let's see. All right, so Matt posted in the chat, what's the relationship between particulates in cities and instability for affecting precipitation?
Well, particulates obviously need condensation nuclei for some of the rain to occur. And in urban areas, you're generating a lot of different particulates, everything from combustion byproducts from PM 2.5 to just, dust and stuff. So, it has an impact. I don't think it's as dramatic as with the urban heat island impact, but, it's very difficult to separate because times when you're liable to have more particulates and all this happening, it's time when you've got a lot of heating and instability and everything else. So,
other questions for Jeff? Well, I'll mention one thing, Jeff. One of the challenges I think we have with working with high school and middle school kids on thermal remote sensing is that the imagery is fairly difficult to process. There isn't really a quick way to get thermal imagery available for your city and to look at the relationship between your imagery and say the surface temperature you take yourself.
Yeah, that's always been a problem, and that's that's been one of my frustrations over the last 25 years because we've been doing this flying the cities since Dale started in '85 when he was working on his dissertation, and when we were doing our big projects in Atlanta and then the 4 or 5 cities we did in the U.S. People would say, can you come fly our city? Can you come fly our city? It's expensive. We couldn't do it. And Landsat's resolution, varied 120 meters, and 100 meters, or 60, or now they claim it's 30. I'm not really sure how they're doing that sampling, but, once every 16 days, that just doesn't hack it. So that's been a real problem, man. It's you can always get the 1 kilometer data from the MODIS satellites twice a day, or you can get continuous at 4 kilometers from GOES. Well, neither of those are really going to help what you're trying to do. Mm-hmm. So that's one of the things I've been advocating now. The ISPRI would at 60 meters, that will give you something you can start to work with, and that's at a 4 to 5 day interval. And we're hoping with the thermal data on space station, that'll help. And that's one of the things. One of my headquarters duties for both the HISPRI mission and EcoStress is I'm the applied scientist for those missions. So part of my duties is to get applications and for this data and this sort of thing. But once you have the thermal data, it's not any different to process than visible data. I mean, it's an image. So, but the real problem is availability or lack thereof on that.
We do have one graduate student on the call, Madhu Sanka, who's from University of Toledo. I know he wants to do his thesis on urban heat island effect, mapping it in Toledo, looking at rooftops, and then using LiDAR to detect the roofs themselves because of the height of the buildings.
Yeah, that's the next step in urban climatology is to get that 3D roughness of urban areas. And I'm just working so far just essentially 1 or 2 dimensions, but obviously that has a big impact too on that.
Yeah, that's one of the nice things in Ohio. The whole state's been flown with LiDAR twice now, and you can get it freely available over the internet. So any questions for Jeff? Well, I want to thank you, Jeff, for calling in and giving us the NASA content for surface temperature and urban heat island effect to give us that context. It was really neat to see the different instruments, and I hope HISPRI gets launched at some time. I know I've been following that for a decade now.
Yeah.
See
And
what's going on.
eco-stress. I'm hoping eco-stress. I'm really hoping we'll get some of the good thermal data. So we're trying to do some early adopter programs and stuff too. So I've got some ideas, and hopefully they'll pan out if the instrument gets up. But the good news is our instrument wasn't on the two that blew up. So it does delay us, but it didn't blow us up.
Right. That'd be devastating.
Yeah. Mm-hmm.
All right. Well, thanks. And we should probably start wrapping up.
Sure.
I wanted to show you guys just to talk about our next webinar. And let's see here. November 30th, so it'll be after Thanksgiving. We're going to go into the background of research with how your students can do that background part. Working with scientists, Rick Sharp from West Virginia is going to be our teacher feature. And then our NASA Nugget is going to be talking about GOES-R, which did not get launched on November 4th. One of those launch things again. And just another finish up with, if you have any questions, you can email Janet. And we have a Facebook page where all these webinars are posted. I think it's also a YouTube page, Globe Mission Earth, if you want to look for it. And thanks everybody for calling in. And I hope you have a good evening. And University of Toledo is playing Northern Illinois University tonight on ESPN. So if you want to watch a good football game, you can tune into that. UT has lost the last 6 years to them. Anyway, thanks everybody, and have a good night.